Good afternoon, ladies and gentlemen. Welcome to the 2025 COMPUTEX Forum, organized by Taiwan External Trade Development Council, TAITRA. In this Data Center Solution Forum, we will examine AI-driven data center architecture, green technologies, and high-efficiency computing solutions to build a sustainable technological foundation. We will begin the forum with a topic that is vitally important in the era of booming AI, liquid cooling. Please welcome our first speaker, CEO of BP Castrol, Michelle Zhou.
大家好，大家好，我是 Castrol Global CEO Michelle Zhou，非常荣幸今天借着这次机会回到我的家乡台湾，代表英国 Castrol 来到台北电脑展。So this year marks Castrol's first time participating in COMPUTEX. And we are thrilled to be part of this vibrant community, shaping the future of a digital infrastructure. Today, I'm here to talk about a very hot topic, quite literally, in the world of the advanced computing, which is liquid cooling. Did you know that 40% of a data center's total energy consumption can be required for cooling? As AI and high-performance computing push the limits of our infrastructure, this is creating major challenges, but also unprecedented opportunities. We're witnessing a pivotal moment in computing, where modern workloads are fundamentally changing the requirement for chip design and thermal management. Today, I will share how we can and must collaborate to meet growing demands and capture this opportunity together. So, for over a century, actually more than 125 years, Castrol has been a global leader in developing high-performance fluids and lubricants that power everything from your cars to the industrial equipment, from the ocean floor to the surfaces of Mars. You could see our application. And today, we are applying this expertise to one of the most critical challenges in computing. That is keeping data center cool, as AI and advanced computing push thermal limits beyond what traditional method can handle. So the latest AI technology are pushing power density beyond their limits. Average power density are expected to rise to over 150 kilowatts by 2027. And this surge brings increased heat and rank density. Traditional air cooling is becoming obsolete, very bulky, energy intensive, and unable to manage growing computational demands. So in response to these changing demands, we at Castrol has launched an industry-wide research paper on liquid cooling. So our tipping point report surveys more than 600 data center experts across 7 countries. It found that 74% of industry leaders recognize that air cooling systems will struggle to handle the increase in data traffic. In response, the industry is turning into liquid cooling to meet today's demand and anticipate the demands of tomorrow. So 92% of the participants considering shifting to liquid cooling by 2030. So industry experts identified 2027 as the tipping point when liquid cooling becomes the dominant technology. But while the industry is clearly moving toward liquid cooling, it's important to remember one thing. The success of these systems depends on on the reliability of one core element, the fluid itself. So why cooling fluids are so important? Because cooling is critical. Overheating can cause servers and hardware to malfunction or break. And this can result in data loss, in downtime, and disruption. Not to mention the cost of a replacement and the risk of a fine if service level agreements are not met. Put simply, when a cooling system fails, a data center fails. And within the liquid cooling ecosystem, the fluid itself represents a single point of a failure. Degraded fluid condition can result in reduced cooling capacity, increased energy consumptions, and early equipment failure. So managing fluid health is essential for mitigating risk and maximizing uptime. And that requires not just any fluid, but one engineered for performance and durability. So you know, Castrol, we are the expert of fluid formulation and management, directly addressing this critical point of a vulnerability. So our extensive testing with server manufacturers ensure optimal compatibility and performance. The Castrol ON range of liquid cooling fluids is built on more than 120 years of fluid expertise, as I explained. They are specifically engineered for extreme demands of a modern computing. Our single-phase dielectric coolants effectively manage the intense heat generated by high-density rack, offering reliable performance and high lifetime stability. We have a developed solution for both direct-to-chip cooling and immersion cooling, providing flexibility for different data center design. Compatibility and reliability are key, which is the reason why we test our fluids with server from all top 10 manufacturers. Comprehensive data and testing data is available for all major server configurations. We are also developing our full fluid offer that will cover all aspects of a data center, including pre-commissioning, commissioning, and operation services. This will ensure the fluids and liquids cooling system is designed, installed, operated, and maintained safely and optimally. Let's take a closer look at how Castrol ON range of fluid can address this single point of failure and turn this into a point of strength. So our fluids are designed to transfer heat effectively. And this will last longer without breaking down and safely protect your valuable equipment. These advantages are proven through extensive testing with all major server brands and all forms of thermal design. Our hydrocarbon-based formulation delivers superior thermal conductivity, making them highly effective at managing heat. And with low viscosity, they will flow very smoothly, maximizing efficiency in heat transfer systems. They are also highly mixable, which help prevent fluid separations and the issues that come with it, like a degraded performance or extra maintenance. On top of that, this formulation offers outstanding oxidative stability, which means they last longer and stay reliable over time. And their excellent dielectric property enhance electrical safety, a key factor in sensitive environment like data center. And of course, they are fully compatible with server components and material, ensuring worry-free integrations. At Castrol, we provide more than just cooling fluids. With operations spanning more than 60 countries, Castrol offers a truly global presence, providing consistent support and expertise in every key market. So you could see our Advanced Technology Center form a worldwide network of expertise with dedicated labs in the UK in Pembrokeshire, where I'm sitting next to it, in San Jose in the USA, in Germany, and in Shanghai. We have established a strategic facility in the world's key manufacturing hubs and key technology centers. We have strengthened our global capability through strategic, also joint laboratories with technology partners across Asia, in Shanghai, here in Taipei, in Singapore, and in Bangalore. In this hub, customers and partners can test and validate components with our cooling fluids, understand how fluids integrate with their systems before deploying them, minimize risk, and maximize efficiency. This global phenomenon or momentum is only made possible by the trusted partners we work with across the ecosystem. So let's take a look at some of the key partners who are building and growing this journey together with us. So what makes Castrol truly unique is in the liquid cooling space is our comprehensive global ecosystem. From direct-to-chip to immersion cooling, as I explained, solution, we have a partner across every layer of the value system, of the value chain, including server manufacturers, tank and CDU provider, to ensure seamless integration, performance, and flexibility. This ecosystem approach, I think, is truly unique, will allow us to tailor solution to tailor the solution for the diverse data center architectures, whether you are deploying immersion cooling or direct-to-chip, or to scale confidently. We are all here to act as a trusted, tested partners for you. And really together with the partner, we are building a resilient and future-ready infrastructure for the AI range. So we are today here in Taiwan, the global leader and hub for semiconductor manufacturing and computing hardwares, from advanced chips to AI server. This really positions Taiwan to be the natural leader in advanced cooling technologies. We are already seeing a significant surge in liquid cooling adoption across Taiwan, particularly in data centers supporting AI and HPC workloads. Taiwanese companies are not just implementing these technologies, they are driving innovation in liquid cooling. And we are proud of our growing strategic partnership with key Taiwanese technology leaders. For example, Taiwan premier server manufacturer, Giga Computing, Compal, Pegatron, all have approved already our direct liquid cooling fluids for use in their systems and conducting rigorous testing. We have also established a very strong partnership with Kentech as our cooling distribution unit partner. This collaboration allows us to deliver complete integrated cooling solutions with local expertise, both domestically and internationally. We see a huge opportunity to continue to support Taiwan technology ecosystem as it grows by forming partnerships for testing and validations, sharing technical expertise and knowledge, supporting and optimizing supply chain for cooling technologies, and co-creating Taiwan-specific solutions with local experts. Lastly, we will also be engaging in key builds of Taiwan's AI data center. So at Castrol, we believe that the future of a data center cooling is liquid. So what is next for Castrol in the data center market? So from the left, you will see we will fully expand our product portfolio into all fluids associated with data center liquid cooling to cover all kinds of cooling loops. So our current focus is on PG-based fluids, purpose-built for direct-to-chip cooling systems, built for direct-to-chip cooling system, as I say, where thermal efficiency, reliability, and material compatibility are critical. We also continue to develop immersion cooling fluid, ensuring Castrol and our partners can support a wide range of technology as the industry evolves. In the middle next, you will see that we will introduce a complete solution approach. That means offering liquid cooling, ready racks, and cooling distribution unit with our partners. And beyond just providing the fluid, we're building a complete service model, supporting the entire fluid life cycle from initial fill to monitoring, to maintenance, to replacement, ensuring long-term performance and peace of mind. So I would like to introduce you to the future of a data center cooling and Castrol innovative service model. And to bring this Castrol's vision to life, let's take a very quick look at a short video.
In 2025, Castrol On is introducing an innovative service model to facilitate liquid cooling adoption in data centers. Fluid thinking, solid solutions. Solid solutions for liquid cooling fluid installation, filtration, system flush, and issuing certificates of analysis. Solid solutions for lab testing, dynamic monitoring, predictive maintenance, and smart dosing. Solid solutions for telephone support, virtual engineers, on-site response, and spare fluid. Solid solutions for liquid cooling fluid collection and disposal. Castrol On will ensure you are ready for tomorrow.
I realize I speak too fast, and I still have 30 minutes left, but I will conclude in next 2 minutes. As you could just see from the video, our service fluids are already enabling the data center of tomorrow. So we believe liquid cooling is the future, and the future is already here and right at our booth. So please can I invite you to visit our booth to see the live demonstrations and discuss your specific challenge or your needs, including the cooling challenge, with our team. So we are located at the booth L1126 on the 4th floor of the hall opposite. And can I also please invite you to download through this QR code the very recent dipping point report that I just discussed. And this will build a deeper understanding and insight into the immersion cooling revolution. Thank you very much for your attention. I look forward to exploring partnership opportunity together. 谢谢大家.
Thank you, Michelle, for your insightful talk. Thank you. The next speech, No AI Without Power. How to Power the Future of AI by Adam White, Division President of Power and Sensor Systems from Infineon, will begin at 2 p.m. Please come back on time for Data Center Solution Forum. The next speech, No AI Without Power, How to Power the Future of AI by Adam White, Division President of Power and Sensor Systems from Infineon, will begin in 3 minutes. Please be seated and set your mobile phones to silent mode. There is no AI without power. Next, we will hear from Adam White, Division President of Power and Sensor Systems at Infineon, to shed light on how to power the future of AI. Please welcome Adam to the stage.
Hello. And hello, COMPUTEX. Are we having fun? Are we excited? I'm telling you now, Infineon Technologies, we are super excited. And why? Join us over the next 20 minutes, and we will give you an insight into this title, No AI Without Power. And of course, I know a lot of you in this audience recognize the revolution that is taking place with the exponential compute power requirements, which of course needs power. And from an Infineon perspective, we do not want to chase the markets. We wish to shape the markets with you, the customers, and of course our ecosystem. Now, I would like to now just test and calibrate you and see in the audience if you can get some of these questions right. Today, AI consumes equivalent of around 2 to 3% of the world's energy, and it's going to be growing significantly as seen behind. And on top of that, the GPU power, I mentioned this incredible growth of GPU. This is growing 10x per the indications behind us, and in fact, growing even further beyond that I'll show you later. And then, of course, we move on to the rack power. And here you can see that the rack power has exponentially grown again 10x for the forecasted projections. When I started, when I had hair, we were less than 30 kilowatts per rack. We will now be talking about collaborations up to 1 megawatt. And then this question. Let's understand, of course, every time we use such agents, the consumption of those 3 questions was equivalent to 1.5 times to 2 times charging your smartphone. So I think now you can understand where we are from the power requirements. In a data center, let's look at this data center here. 100,000 GPUs and beyond in a traditional data center. 100,000. And you can see us here building up all of the subcomponents of the data center. And you can see, of course, we go right the way from the switching racks, the power supply units, the backup supply units. And then you go into the compute tray. And again, there is lots and lots of power requirements going into powering the GPUs or TPUs, and then the smart NICs. Infineon we're of course proud. We actually cover 100% of the power conversion steps. This to us is of course a key element that we wish to work with our ecosystem partners. Okay, so as I said, 100% coverage. And what do we mean by that in the power management areas? We mean the drivers, the switches, the power stages, the microcontrollers that are customized to make sure that they get the best out of the system. New families will also be launched. You can see here we go right the way through to modules, especially we'll talk about the 1 megawatt racks in a moment. And then on top of that, even sensors, magnetic sensors that we're providing into the data centers. Now, what I like to do is actually go into now a deep dive. And we will start in a very exciting area, and I know a number of our customers are in the audience around power supplies. And what we'd like to do is really just explain to you that over the last years, we Infineon have been developing latest technology, not just in silicon, but in silicon carbide as well as in gallium nitride to support the evolution of the topologies needed to power these racks. Now, these power supplies, anything, traditionally from 3 kilowatts up to the 3.3, you can do in a traditional, conventional way. As we move above the 5, getting to the 8, getting to the 12 kilowatts, that's where, of course, we need the latest technology coupled with the right topologies that we will be supporting with wide bandgap, namely silicon carbide and gallium nitride. And for your reference, and a little bit of a teaser, we're also developing 12 kilowatt three-phase solutions for the next architectures. And of course, these go up in scale as well. So as we work with the ecosystem partners, the power supply companies, we know that this is at the very beginning, and we are looking forward to bringing out this technology. Now, this is the next insight. This is a traditional AI rack server. You understand that we have the power delivery and backup area, and we have the IT payload. Overwhelming demonstrations here in COMPUTEX. This, again, without going into too much detail on this slide, is the standard topologies that are used. Here you take in the AC, you take it into the single phase, then of course you have the BBU, as well as the supercaps, and then you convert, let's say for example, down to 50 volts, and then you can do the IT tray conversion of the intermediate bus converters. All good. That makes sense. It's needed. But this will not get us to the future. What will get us to the future is what we've announced today. We actually have a collaboration with NVIDIA, and we will be looking at the next architectures to support the 800 volt DC architecture. And of course, we have the IT payload, but the key thing is we're looking at a centralized ability to centralize the power delivery and the backup units. Now, this is going to be pretty groundbreaking. And at the end of the day, of course, why are we doing this? And why do we believe in it? And why are we now collaborating with NVIDIA? This isn't about today. This is about as we move forward to the end of the decade. And we recognize, of course, the benefits not only in efficiency, not only in reliability, because you remove the needs for all of the separate PSUs, power supply units, you go centralized. You can also increase then, ultimately, the benefits of bringing that voltage, the 800 volts, in directly to the board. On top of that, the copper that is needed. And this scales. This scales to 1 megawatts and beyond. So, with this announcement, let me just take a few more moments to really show you how this is actually going to be used, as if I would call it the North Star. So first of all, you have the infrastructure, the medium voltage, whatever that 13 kilovolts, whatever it may be. That then, of course, will give you then the ability to convert the AC there into the DC, to create effectively the 800-volt backbone, down to 0. And then there, from the infrastructure area, you can have the long-term storage. And this is, of course, based upon effectively the standard capacitor technologies that are out there today, the electrolytics. Then from there, we will move that into the hall. And you then got a requirement for the medium energy storage, where you would use then, of course, the supercapacitors. Again, straight off that 800-volt rail. And then again, going now into the IT row, you have the ability to do the short-term storage, again on the standard electrolytic capacitors. Again, on the 800-volt. Then the magic happens, because you are bringing that voltage straight into the motherboard. And that's where you can convert the high voltage intermediate bus converters, as well as the medium voltage intermediate bus converters, then back into core. And we recognized this as Infineon some time ago. And that's why we've been developing technologies like gallium nitride to make sure that we get the maximum ability to switch at higher switching frequencies to get the efficiencies as well as the densities. And we will be taking that 800 volt down to a nominal 54 volts, or we can, of course, bring that down to the 12 volts. And the same for the low voltage, as well as, of course, on the VRM. We can use the technologies of silicon as well as gallium nitride. So this, again, is the North Star. There's lots of topics that we need to be working on. We need to make sure it's protected. But again, moving away from the 54-volt rail, moving into this 800-volt, and, of course, going into the DC plane, we can then work on this to bring in the efficiencies, the reliabilities, and, of course, it will help overall the scaling factors as well. Now, that's good. But as we work within NVIDIA, we have to also be somewhat realistic. And that's why we are saying, look, there is an intermediate step, a phased approach. And the first step there is on the IT payload. And then there will be a sidecar, of course, that will have the power delivery backup. So this will be the intermediate steps that we will be driving. And again, on the topology, I won't need to repeat it, but you can see here going in from the AC at the top, going in now all the way down to the sidecar, and then, of course, giving the compute rack the right level of density and efficiency that is needed. But again, we are super excited about moving to the end goal before the end of the decade. And we recognize Infineon, and we recognize NVIDIA. We can't do it by ourselves. We need you, the ecosystem, the customer base, to come along this journey with us. And we will talk a little bit more about that later. Let's do the next deep dive. This is the intermediate bus converters. And again, this is the first power stage conversion. You have the high voltage IBC. These can be based upon the LLC topologies, where you can go to the 50 volt to the 12 volts, inductor, capacitor. That, I think, is also known. And then from there, we can do the medium voltage. And again, you can go down from the 12 volts, 6 volts, whatever is required. Now we're bringing something else new to the industry. And that's something new, is what we call an interleaved buck converter. You've heard it here for the first time. And why? Because we're going to be bringing this technology to market, and what we're going to be doing is using gallium nitride. And this is an example of the benefits of the 1.2 kilowatt base scalable solution. So first of all, look at that efficiency level. Look at the figure of merits. If you're in this space, I ask any of you now to look at this efficiency level and see how you can do it at the density that will be achieved with gallium nitride. And then, of course, the digital control. This will be giving us the advanced fault control. And then, as it says in the title, the subtitle, this is a modular approach. So we go to the 1.2. We can then, of course, scale this up to the 4, to the 8, to the 10, and beyond. The modular approach works with the interleaved topology. On top of this, we've got the transformerless as well, which brings lightweight, reliabilities. You can understand what this could bring for the industry. And then finally, that will reduce the switching losses. So we, again, are really excited about this area. Now, another area that we wish to talk about is now the really exciting topic about how we are powering and teaming up with the world's leading GPU vendors on the planet Earth to make sure that we understand their requirements. And as you saw before, going from these 450 watts going up to now greater than 3,500 watts for the GPU. That is a challenge in power. But with that challenge, clearly brings these opportunities. And with that then, we would like to show you the next evolution of voltage regulator solutions. Let me talk you through this. You've got the GPU substrate motherboard. You can put then the components basically laterally next to the substrate. The next evolution will be the vertical power going underneath the substrate. We believe 8 to 10% system performance. This then ultimately will move into substrate integration for vertical power. Again, another step increase of a system efficiency. Ladies and gentlemen, what we have on this slide, this is not fiction. This is reality. This is us as an industry, and especially here with Infineon Technologies, working with the leading GPU vendors to make sure that we understand not just next generation, but N+2, so we can provide the requirements on the power management to achieve the ultimate goals. Now, I'm sure a lot of you are saying, well, how's this done? Where are we? Let me just walk you through a little bit of a journey on these power stages and these module solutions. So we started way back in 2011. We got 0.4 millimeter squared performance amps, millimeter squared amps. And then from there, we started to develop an ecosystem around chip embedding. That's not easy. We had to go and find partners in the industry that could do chip embedding, and of course, at these current and power levels. We then created that, which went from 0.6. Then we went to 1 amp per millimeter squared, and then the journey continues as we bring out the family of modules, 1.5 and then 2 amp per millimeter squared. Now, one thing you will notice, it took us a decade to go from the module over module solution, to then effectively going into the chip embedding. But effectively, since 2024 until now, we've 2x'd the amp per millimeter squared. And that's not where we stop. Per the video that you have just seen, we will be going above the 3 amp, and of course, we'll be going eventually above the 4 amp per millimeter squared in our labs as we speak. Now, saying that, all of these have to hit certain fit-form functions, height, density, performances. So that is a topic that we are looking forward to bringing out the leading-edge solutions for VRM. And of course, what does this mean? This means energy efficiency between the 8 and 10%, and I would say, and beyond. It also improves the power density between 30 and a staggering 60%. And then ultimately, on top of that, the best-in-class robustness as well as reliability. We take that incredibly seriously. Maybe it's a bit of the German DNA of Infineon. Maybe it's our heritage of automotive and industrial. But we will not compromise on quality. And we understand the downtime and the reliability needs in these data center and these racks, the uptime. And that is something that we are very, very cautious of and making sure is the front of all of the designs that we do. And on top of that, Infineon, we're proud here because we recognize that if we use today in the data centers that are installed the latest technology, we can save a staggering 22 million tons, metric tons of CO2. In simple language, that's equivalent to 7.5 million combustion vehicles. And that's where we are today. Can you imagine what it's going to be like moving forward? 48 terawatts an hour you can save using Infineon technology. That's equivalent of all the electricity that is used today in Portugal. And then from there, we also understand we have to have best-in-class total cost of ownership. All of that other technology and innovation, we wish, of course, to address these 2 key points. So you can see we are super excited. First of all, in summary, we recognize that this innovation and collaboration with NVIDIA will take us to this North Star for the future power distribution for data centers, accelerating compute power. On top of that, we're not going to be able to do it, we believe, as an industry, just with silicon. Wide bandgap materials will be required. Whether it's on the silicon carbide for high voltage modules, as we go in from the MV, the 13 kilovolts, going into the 800 volt solution, or moving forward as we switch higher frequencies to support density and efficiency with the gallium nitride. And it wasn't so long ago, gallium nitride was, yeah, okay. We've also launched the world's first 12-inch gallium nitride wafer. We're moving to 12-inch on GaN. This will be required to support the demand that we see how GaN will be so disruptive. And on top of that, on the silicon, we have teams today walking around COMPUTEX. They're not just working on the next generation silicon solutions for AI. They're not just working on the second generations. They're working on the third generations already. Because we recognize that silicon will also have a strong play. And then, of course, the total cost of ownership. And my last sentence here, if anybody's following Infineon, we have this responsibility of not only driving digitalization, but also decarbonization. Thank you very much.
Thank you, Adam, for your powerful talk. The next speech, The Future of Sustainable Data Center in the AI Era, by Colin Priestley, VP of Customer Engineering from Seagate, will begin at 2:30. Please come back on time for Data Center Solution Forum. The next speech, The Future of Sustainable Data Center in the AI Era by Colin Priestley, VP of Customer Engineering from Seagate, will begin in 3 minutes. Please be seated and set your mobile phones to silent mode. Next topic, sustainability. As we move full speed towards an AI-driven future, we must not forget that the world is facing the unprecedented challenge of climate change. Industries around the world are striving to optimize their operations and embrace more sustainable practices, and data centers are no exception. Our next speaker, Colin Priestley, Vice President of Customer Engineering at Seagate, will explore the future of sustainable data centers in the AI era. Let's welcome Colin to the stage.
Hello. It's really, really good to be here. This is my first time at COMPUTEX, and it's been an amazing time. It's just amazing to see the innovation in our industry. So before I dive into my talk, I would like to start by just giving you 4 assertions, and then hopefully those will validate themselves as I talk to you a little bit about decarbonizing data in our data centers. First assertion. I think all of us would agree that our world economy has already transitioned from a digital economy to a data economy. The value of data has really never been greater. And that is driven by AI and the ability to actually extract value from the data around us. Number 2 assertion. The volume of the data is exponentially growing. Not just with the GPUs of today, but from IoT of before. Even a few years ago, we were talking about machine-to-machine and generation of data. Now we're talking about GPUs and Gen AI and all the ways that new data can be created. So the volume of data is exponentially growing. Number 3 assertion, that the data processing that is happening today is amplifying the carbon footprint in our data centers. And that's becoming a real problem for us and our industry. Number 4 assertion, the technology innovation around us can decouple the trajectory we're on from carbonization and cost. So hopefully through my talk, you'll be able to see those things come through. The value of data, the volume of data, the amplification of the data processing and the carbonization, but the promise we see through technology innovation. So let's talk about the volume of data. So IDC is an industry analyst that we use in our storage industry to project how much the data is growing. And you can see that from 2023 to 2028, we're going to see 3 times the amount of data in our data sphere. So for those that aren't familiar with what a zettabyte is, a zettabyte is 1 billion terabytes, or 1 trillion gigabytes for people that work in gigabytes. It's a number that's almost unfathomable. To give you some reference, Seagate, from the hard drive industry, we can create about somewhere, as an industry, we can create between 1 and 2 zettabytes of storage per year. It's extremely small versus the amount of data that's being created. And this data is being created all around us. Smart cars, smart cities, our smart universe. The data creation is incredibly massive. And really the million-dollar question for us is how much this data will be stored. Or maybe a better question, how much should be stored? Or maybe even a better question than that is, can we even store this data sustainably? What is it going to do to our data centers and to our industry? So at Seagate, we went out and we created a couple of surveys to look at the industry and try and, this is a big problem for us, right? We need to understand how big the storage industry is going to be, how we can scale, how we can grow. And so one of the surveys we put together was a mass storage survey, and we asked 1,000 IT professionals, are you using AI today, or do you plan to use AI? And you can see 100% either use AI today, or they plan to use AI. And you can see of the 72% that are currently using AI, 90% of those agree that retaining more data provides better AI outcomes. It just is very intuitive. And so this is something we've been tracking very seriously, because what we're hearing from the industry is, Even today's models need to use data that has been retained from years prior. So people are very, very reluctant to throw away the zettabytes of data that are being created. And this is becoming a big growth engine for our industry. So we then put together a second survey looking into data center sustainability. And we went out and we talked to a lot of industry professionals, more than 300 data center professionals, and started asking, what are the barriers to sustainably growing your data centers? And you can see here the top barriers. One, high energy consumption. That shouldn't be a surprise to everybody. Raw materials is the second. Physical space constraints being the third. Infrastructure costs and acquisition costs. So you can see right at the top of the list is energy, and that makes a lot of sense, right? In today's economy, especially with the GPU transitions, data center energy is becoming a significant barrier to growth. And we, as a storage part of the industry, look to try and augment solutions to make sure that we can provide solutions that the data center can still grow sustainably, even in the barriers against the power that we're seeing. So how do you solve this dilemma in the data center? The first way is scaling up. You increase the resources in the data center, but that's limited by space and specifically by energy capacity. Often the energy infrastructure around the data center is a fixed mechanism, and it's very, very difficult to upgrade. So there are limitations in which data centers can actually just purely scale up their capability. The second way is to scale out, build new data centers. High cost, space, again, is an issue. And the energy availability is also an issue. Where do you put your data centers? Is there available power? These are a lot of considerations that our industry is struggling with. The third one is migrate to the cloud. Now, that's not necessarily mutually exclusive to the first two, but what it does do is it centralizes the problems within the companies that are best suited to solve them. The big cloud providers have extremely smart infrastructure engineers. They have very high scale, very high efficiency, so they can solve these problems better than we can do at small scale, but the problems fundamentally don't go away. So TCO, total cost of ownership and cost, and sustainability are essentially at a crossroads. When we talk to those professionals in the survey, 95% of them are concerned about the environmental impact to growing their data center footprint. However, only 3.3% prioritize environmental impacts when they're doing their purchasing decisions. When we look at extending the life of IT infrastructure, 92% agree that the life cycle impacts sustainability, but only 15% rank life cycle as a top factor when making purchasing decisions. So you can see at the moment in our industry, sustainability, carbon footprint, while it's top of mind to a lot of our procurement people in our industry, it's not the dominant purchasing decision. But as we look to the future and the problem that we started with in terms of the volume of data increasing, we need to solve this. We cannot be on the same trajectory we're on. We need to find solutions to break the crossroads here that we have between these two somewhat conflicting requirements. So the rest of my talk, I'd like to talk about how these two aspects don't necessarily need to be conflicting. They don't need to be trade-offs. They can go hand in hand. It just takes intention, and it takes dedication and innovation to try and solve these two seemingly unsolvable problems. So this slide shows how cost translates to carbon. So if we are going to solve this problem, there is no silver bullet. It takes a really holistic approach across the data center to tackle the issues we've been talking about. First, you can see that There's life cycle extension. How do we get more out of the data centers we have? Trying to lower the infrastructure costs, we'll talk a little bit about that soon. How do we reduce the energy consumption? What can we do about raw materials? Are there ways we can recycle, reuse, renew? And then what do we do about physical space constraints? These are 5 aspects of solving this problem, which ultimately lead to reduction of carbon in our data center footprint. As we look at carbon and how we measure it, we talk about 3 scopes to carbon and sustainable future. And we're all accountable in the industry to try and reduce these. Number 1 is just direct emissions from what's controlled by any individual company. The number 2 is the operating cost of that infrastructure, typically power, goes into scope 2. And then scope 3 is all the indirect emissions from the value chain. So that's the supply chain. How do we source our materials? How do we source our processes? All of these things are important, and they get measured. And this is a big focus for Seagate, and a lot of the industry as well have very sustainable goals around greenhouse gas emissions, and they're measuring directly the scope 1, 2, and 3 impacts to our industry. So let me pivot and talk a little bit about how Seagate are trying to address some of the greener aspects of data centers. So let me talk a little bit about areal density. From the life of the beginning of the hard drive, and really any storage medium, areal density innovation and advancement has been the lifeblood of our industry. By packing more data into the same space, not only do we solve the space issue, we solve the power issue, and we solve resources. It solves all of those things because by packing the data tighter, you're getting a lot more use out of the same amount of area. And I'll talk a little bit about some of the advancements we have in our areal density capability. Specific to the hard drive, we've now got an innovation called dual actuators, where we actually put 2 physical actuators inside a hard drive. We can actually double the performance of that device within the same footprint. Now, why is that important? And why am I talking about it in a sustainability and a carbon perspective? Well, if you need performance out of your storage, the only way of getting it today is by scaling out. So you have to put more spindles online. That's really the only way because there's a fixed amount of performance within a hard drive. If you can put 2 actuators into one device, you can double the performance of that device. Now you're getting double the amount of performance within the same device, and you're halving the amount of power you need to access that same amount of storage. So it becomes a very carbon efficient way of deploying storage at scale. Circularity programs. More than 200 million, I'll say again, 200 million hard drives are shredded every year, turned into dust. They're coming out of data centers today because of lack of trust around security, that they're taken out, often they're degaussed, and then they're put into a shredder and just turned into dust. That clearly is not a very environmentally sustainable thing to do for our industry. So you get actively promoting circularity programs where we can refurbish, we can repurpose, and we can recycle. We have programs where we can actually extract the magnets out of the drives, and we've reclaimed more than a metric ton of magnets, which contain rare earth materials, which are very, very difficult to source in our industry. So clearly keeping e-waste out of landfills is a clear priority for us, and it should be for the whole industry. Supply chain accountability, that's extremely important to us. Choosing sustainably driven suppliers and pushing all these concepts back into the supply chain so that we can get the most efficient supply chain from a carbon footprint perspective. Security, again, it doesn't often, you see security as the why is security linked to sustainability. But when we talk back to the fact that so many devices are getting crushed coming out of our data centers, we've now invented some really, really powerful encryption techniques that reside on the drives and allow instant secure arrays of the drives so that we can throw away keys and you can essentially reuse the drives. So there's now techniques that Seagate and the industry have been working on with NIST and ISO and standardization so that we can use our drives for longer and keep them out of the landfills. And then we have ADR and adapt here. These are a couple of techniques that Seagate use, but generally are used in the industry at large. ADR stands for autonomous drive regeneration. We now have techniques where we can actually take a drive. If a single surface or a head fails in that drive, we can depopulate it and reclaim the rest of the drive. So today's hard drives have 20 heads typically. We can depopulate that one surface and keep 19 heads alive. Keep that drive in surface longer, which again adds to the benefit we see relative to the decarbonizing the data center. Adapt is essentially a smart RAID feature we have in our systems, but is used generally industry-wide. With erasure coding and RAID systems, you can increase the redundancy of our systems and again, keep drives alive longer in the field and not have to pull them out because of single sector errors or single failures. So let me talk a little bit about areal density. So what you're seeing on the screen here is Mosaic 3+. This is Seagate's incarnation of what we call HAMR, or heat-assisted magnetic recording. The hard drive industry currently is at an inflection point in areal density capability. We've had two big ones across our industry. Back in time, we used to do longitudinal magnetic recording, where the bits were essentially lying down flat on our magnetic surfaces. We then moved to perpendicular recording, and the bits are standing up, and we got a big jump in areal density by reorientating the bits on the disk. We're now going to this technology called heat-assisted magnetic recording. And Seagate are leading the way. We've put significant investment into this technology, over 20 years of R&D, more than $1 billion of investment to get this to market, and now we're actually launching it and we're starting to ramp it at scale. Just to orient you to some of the features you're seeing on the screen, the big invention is that big laser you'll see in the middle. We're now able to integrate a laser into a hard drive, and that laser can heat a spot on the media that is the size of 1 bit. It heats the media to 800 degrees Fahrenheit and down again to nominal within 2 nanoseconds, and it creates a very locally induced reduction in coercivity that allows us to increase the coercivity of the media around it. So if you see the base plane there, you'll see a series of what look like hexagons. Those are the magnetic grains. And the magnetic grains are fundamentally what define the areal density of disk drives. And it's a sputtering technique that we do at very, very efficient capex and cost. So by integrating the laser, we've now got to a point where we're able to break away from the traditional perpendicular magnetic recording paradigm, which was reaching a limit, and unlock a new era of areal density innovation, which we can't yet see the end of. So we're just introducing this Mosaic 3+. This is going to be 3 terabytes per disk. We already have in our labs demonstrations up to 6.5 terabytes per disk demonstrated, which would represent on a 10-disk drive a 65 terabyte hard drive. Today we're shipping between slightly north of 30 terabytes. So you can see that by the innovation and unlocking areal density, we're on a trajectory to increase the areal density of disk drives, which is going to bring the power benefit to the data center, the TCO benefit, and the decarbonization that we're looking for. So just to summarize the advantage of investment in areal density, scale is a big one. You can see that we're now replacing approximately 10 terabyte drives in data centers with 30 terabytes. We're getting a 3x improvement in storage capacity. The 3x capacity translates about 25% lower dollar per terabyte just in terms of cost. And then from a sustainability perspective, the extra areal density and power per terabyte gives us the sustainability benefit that we want for our industry. So we talked a little bit about scope 1, 2, 3 and greenhouse gas emissions, and this is a study that was done to look at storage media and how they relate to each other relative to embodied carbon, which is a combination of the scope 1, 2, 3 greenhouse gas emissions and energy efficiency. Now, the takeaway on this slide, obviously the first takeaway is you see that the hard drive is actually the most efficient relative to embodied carbon, but I really want you to take away that this doesn't mean we should be deploying hard drives everywhere, even though 90% of our data centers are filled, bytes are filled with those. The takeaway really is to be very, very intentional when you think about storage architecture. SSDs are a great invention, and we need SSDs as a hard drive company to scale in capacity because they are the front end of the storage media, and they're the storage that sits next to the GPUs that are enabling the growth of data centers and our industry. But relative to carbonization and efficiency and cost, you really can't beat the hard drive solution. Even against the tape in certain cases. When a tape is online, you can see that the power efficiency isn't even as good as a hard drive. So really just to have the takeaway on this slide, it should be that think about embodied carbon when you're putting together storage infrastructure. The biggest and the best cloud service providers are deploying all of these storage mediums in a ratio to best optimize the TCO and to think about carbon efficiency as they scale their data center footprint. So as I start to wrap up, I'd like to bring attention to another piece of innovation that we actually have showcased here on the floor in the Seagate booth, if you'd like to stop by. We're now starting to talk about adding NVMe to hard drives. So NVMe is not a new interface, right? It's now become the standard pretty much in SSD. But in hard drives, we've had SATA and SAS now for many years, and we're starting to talk about adding NVMe. Now, why would we do that? Well, I say go downstairs and see. It's a really cool demo. We actually have native NVMe direct attached capability. We've integrated NVMe inside our silicon, and we're the only hard drive company that's demonstrating this capability. In the demo downstairs, you'll see we have an ARNIC, we have a DPU, we have an NVIDIA system. We can actually direct connect hard drives through the DPU into the GPU. This is all about simplification of the interface. Now we got one interface across storage, across SSD and HDD, and proximity. So now we're bringing the hard drive from a proximity point of view right next to the GPU. Clearly, we need SSD there too, and you can see there's an SSD cache. We can't absorb the speed of the data on a hard drive array that's needed from an inferencing workload. But keeping it proximally there with next to the SSD with the native interface capability is really the best optimal solution, and we're starting to look towards the future of storage, and could NVMe become the one unifying interface? Now, more to come on this. We haven't announced the product, but we are looking to get feedback from our customers. We're heavily involved in OCP and to try and define the standardization of how an NVMe interface would look on a hard drive. And we're getting very, very good feedback and interest in the industry. The connectivity is very standardized around SATA and SAS connectivity. So a single lane NVMe hard drive would connect the same way the SATA drive does today. And a dual lane NVMe would plug the same interconnect the way a SAS drive would today. So you'd have 2 lanes of NVMe. So a lot of effort has been placed into legacy systems and how we can integrate our new technology into legacy systems. And we're excited to hear the feedback of our customers as we showcase this and trying to decide exactly when to introduce this into the industry, especially as a lot of the larger customers are starting to put together very custom silicon solutions and looking to potentially even deprecate SATA from their processors and going direct NVMe. So once that happens, having a direct NVMe hard drive solution just really increases the probability of being able to keep SSD and HD together and scaling them in the most optimal way. Okay, so just to wrap up, hopefully you'll recognize the 4 assertions that I started with. That we're in a data economy, that the volume of the data is exponentially growing, that the processing of the data is amplifying the carbon footprint of our data centers, and that technology innovation can really help decouple that amplification. We're in the age of AI. We need to be in the age of sustainable storage, and innovation is more important than ever. AI is what's upholding our next era. It's the data that's upholding AI, and it's storage that's upholding the storage upholds the data. We need all 3 to work together to be successful. Thank you for listening.
Thank you, Colin, for your insightful talk. Thank you. The next speech, Powering the Future of AI by Pankaj Sharma, EVP for Data Centers, Networks and Services at Schneider Electric, will begin in 3 minutes. Please come back on time for Data Center Solution Forum. Ladies and gentlemen, please join me in welcoming Pankaj Sharma, EVP for Data Centers, Networks and Services at Schneider Electric, to share his view of powering the future of AI. Let's welcome Pankaj to the stage.
Hey, everybody. Well, this is a long stage, huh? Takes a bit of a walk. How's everybody doing today? Yeah? Is there still some energy left in the room? Yeah? Well, for those of you who stayed back for the session, we'll probably give you an award later. Right? But look, you've heard a lot since this morning. Starting point was NVIDIA as I was looking at the information. So you started with everything about compute. I was actually listening to the last session from Seagate. Very interesting how they talk about storage and the future of storage. So I think bringing it to this session for now and actually trying to talk a little bit about the physical layer of everything which is compute and AI is what is going to be my goal for today. Okay? So next 30 minutes, what we'd like to do is to share with you a couple of things. But first, let's lay out a bit of background, a little bit of information. As you can see on this huge screen here, the adoption of AI, right? The adoption of Gen AI in 2 months has been equal to the adoption of everything related to the World Wide Web in 7 years. Just put that in perspective. And I think a lot of us here, or most of us here, would have experienced the World Wide Web. And maybe if some of you are really young, then you probably don't know what that is. But with that, if it is 2 months, that means the amount of data which is getting generated is phenomenal. Compute, storage, you heard a lot about all of that. But now think about the amount of electricity which is needed to run these data centers, right? And on the other side of the page, you will notice how the increase in electricity production is going to be over the next couple of years. So these two very important aspects from both data getting generated and adoption and to the energy create the challenge in front of us, which is all about building sustainable data centers. There's a growing demand. The reality on the planet is that there's still about 3 billion people who do not have access to electricity. And then a lot of us, most of the companies out there, have to meet their net zero goals. How do we do that? Again, a little bit more in terms of perspective. It's the next industrial revolution. I'm sure you've heard a lot about it already. It's touching every aspect of our lives. I think we are all experiencing what AI can do for us in different ways, whether you're a consumer, whether you're running a business, you're running a hospital, you're running a large environment, you see it everywhere. So there is a capital part of this whole industry, which is about how much money is getting generated or getting invested into this industry. So the total market capital for generative AI, just Gen AI, is going to be close to $1.3 trillion. Trillion dollars. That's a huge amount of money. But then think about the amount of investment which is going into this industry. The investment is a lot because a lot of private equity is now also getting into this space. Year to date, this year, it's been only less than 5 months, more than 60 billion has gone into this industry in terms of the investment of the physical layer. So it is also important to then think about that, yes, there is this energy challenge when you think of AI. And everybody speaks about the energy challenge. What we like to speak about at Schneider, obviously, is to focus on the energy challenge, but also focus on what AI can do to simplify the energy challenge. And these two pieces have to work together, and they have to be able to optimize each other. And we'll share a few examples today on how these two pieces can actually work together. First, a starting point, and this is, I know it's a slightly busy slide, and you'll have access to this white paper. The information here talks about 4 scenarios on how energy consumption of data centers will increase over the next couple of years. And as you can see, there are 4 colored lines, and there are reasons for those colored lines. The yellow one on the top is like almost unconstrained growth of data. which means unconstrained availability of energy and whatever it takes to build those data centers, it'll go in that fashion, which is really going up. Then there are a few other scenarios out there, and then you'll see a red color line, and the red color line basically indicates that if there is really no way the world can have the amount of energy which is needed for these data centers, then obviously you can't get that growth. In any case, the point being of this page is that the growth of the need for energy is growing dramatically, but there is a way to bend this curve, and we call it the bending of the energy curve. Okay? And I'll explain a little bit more in the next couple of slides on how we can do that. But before we get to that, let's all be clear. AI is vital for decarbonization. And I'm actually going back to my earlier comment, which is, yes, energy. A lot of energy is needed for AI, but AI can also help in reducing the amount of energy which is being consumed in this industry for data centers. So AI is actually playing an important role there. And what you'll see on this page is an example. And let me take a couple of minutes to explain this, because this is important to keep in mind. Now, when you think about AI, typically what AI would do is look at data in your environment, in your business, in your, whichever environment you're in. That data is, then you set up some algorithms based on which the data is crunched and there are some insights which come out of it, right? So that is what Gen AI does. Now, of course, agentic takes action, right? So that's the agent models. But all of that data and all the information which comes out and the insights which come out, the goal of that information is to make the operation of wherever this data is more efficient. That's the whole point of doing what AI does. What you see here is an example, which is basically in the buildings environment, in one of our customer locations. Over a period of 4 years, when you apply AI to the functioning of the, in this case, HVAC systems, which is cooling systems of that environment, and then applying those new models through the LLMs and actually getting insights, then applying those insights back into the operation of this environment, you're able to get close to 3% reduction in the utilization of the district heating, which is a lot when you think about from a financial standpoint. 9% reduction in electricity consumption, which is again a lot, not just from a financial standpoint, but also from the perspective of sustainability. And then so much more in terms of decarbonization, et cetera. So this is one example, if you look at it, this is one example which explains how AI can actually help in reducing the need for energy for the whole AI in itself. So that's why AI for energy is an equally important concept versus what we always talk about, which is energy for AI. Okay? So hopefully this helps, and we have plenty of such examples at Schneider Electric. Obviously, we're working with many of our customers who are able to get these kind of results. So the electricity consumption of data centers is basically all linked to availability of power. I think this we all understand. We can think about a lot of zettabytes. You just heard about zettabytes of data, which has to be stored or computed, et cetera. But end of the day, if we do not have enough power available, you cannot build those data centers, which means we cannot realize the benefits of what we are talking about around AI, the efficiency and so on, et cetera. So the challenges around that are multifold. Availability of power, I spoke about that, but availability of green power, sustainable power. That's the goal, because if we think about sustainability for the planet, it has to be clean power. Capacity, so which is the availability of power. Vacancy rates. Data centers, a lot of data centers in the world today are running full in terms of utilization. So which means if you need to have more compute to be done, you need more data center space, which means you need to build more data centers, which is obviously then causing rental rates going up, right? It's a demand and supply situation. And then the design part. And the design part is a little bit critical, and I'll take a second to explain this. In the past, the way data centers were built, they were built to a certain capacity of between 15 to 20 kilowatt a rack, right? Now, but when you think about the AI factories, and you've heard a lot about the AI factories this week or in the past weeks, including during the GTC of NVIDIA, what you hear is that we are already close to 70 to 100 kilowatt, And we are potentially going in the direction of almost a megawatt a rack. So what that means is we need to relook at how we design these data centers. And design then plays an extremely important role, both in the greenfield, which can be relatively easier, but equally important in brownfield, because there is a lot of brownfield data centers. And when I say brownfield data centers, here's an example of what already exists. Again, apologies for a busy slide, but if you look at that number 105, what it indicates is the installed gigawatt capacity, which is as of this year, 2025 is what we are talking about. Within which, now this is all capacity, all compute capacity, within which generative AI is close to about 13%. So that's where it stands today. It's important to make that distinction between the rest and Gen AI, because Gen AI gives much higher compute, which means it needs much higher per rack kilowatts. So that's 13%. It's supposed to go to almost 36%, but the overall gigawatts will go to 255. Now, what you have in the 105 and in all the previous years is a lot of that is brownfield. If you have to shift that into an AI factory, a lot of design change has to happen, which was the connection I'm trying to make to the previous page. But the point on this slide is that 60% of the new deployment is all Gen AI, which means it's all accelerated compute, which means it all needs much more energy, all needs much more kilowatt per rack, and hence, what is the challenge at hand around the need for energy? The average densities, as I mentioned, are changing. We are talking about 40 to 100 kilowatt now. In the past, it used to be 10 to 20. And all of that, again, means the need for energy going up. And what you see there are three different type of lines going up, but these are just different agencies making their own analysis. But eventually, it's all really the need for high density requires much and more power. So, welcome to the new era of data centers. Don't worry, I'm not starting my presentation now. I will finish on time. But the reason I'm saying I'm welcoming you to the new era of data centers is because what you would have heard in what I said in the last 12 minutes is really trying to articulate how all of what we speak about AI, all of the benefits of AI, which we notice ourselves or we notice in the large business environments, what does all that mean in terms of what kind of data centers have to be built? I'll give you another little anecdote. Early this year, we had the Davos event. I think most of you have heard about the event. And I went to the Davos event. It was my first year. It was very interesting to sit through so many panels where there are so many companies talking about using new LLMs and coming up with great Gen AI models, which will bring efficiency to the operations of different businesses. Very interesting. But when you ask them the question, so where is all this going to sit? They'll say, yeah, there's some data center somewhere. Okay, but which data center and where? The understanding of the physical layer overall at a global level, unfortunately, is still rather limited. It is our responsibility, companies like Schneider Electric, to bring it to that level. And that's why we are saying this is the new era of data centers and how we explain how these data centers can be built. So in this new era, there are a few areas which need to be kept in mind. There's a rapid compute evolution. We already spoke a lot about it. You already heard a lot about that from NVIDIA as one of the main players in this field. You've heard all those names from NVLs and going up to the Rubins and then the Rubin Next and so on. This all needs ultra power density, and I mentioned that a little bit already in terms of per kilowatt rack, but at a chip level, the number of outages are going up also. Race for AI leadership. Now, this is an important aspect. The reason it is important is because there are all these large companies who are our customers who are actually in this race simply because they are able to take their existing infrastructures, build new data centers, and give that as a service to all of us. So then we become their customers, whether we are large companies like Schneider Electric, or if we are smaller businesses, or if we are any other environments. So that's the race, and which means all of this needs to be built fast. And it's also a race because we need to keep pace with what is coming from a compute perspective. And if you see the roadmap, and I think maybe on the next page or one of those pages, you'll see the picture where how NVIDIA is talking about the compute changing. So that evolution is so fast, we have to keep pace with that. Hence, it becomes fast-paced. Power profiles are fairly dynamic now. They're not static. Dynamic means that you have to be, when you build this data center environment, you have to be able to tolerate and the amount of power which is needed and how the spikes, et cetera, are happening. Because in a training cluster, that becomes another important aspect. And then finally, the architecture variability, which I already explained in terms of whether it's a brownfield data center, a greenfield. If it is an existing 50, 20 kilowatt, has to go to 100 kilowatt or more, et cetera. So that's the reason why all this becomes so special. So what is needed then, you need an end-to-end solution. Solution being starting with a sustainable data center. Like I said earlier, even if there is available energy, we need clean energy. Even if there is a capacity to build these data centers, with all the equipment, whether it's powertrain, cooling, et cetera, Schneider does, many other companies do that, it all has to be sustainable. That has to be one mission. It has to be able to take care of the high performance which is there. So that means the powertrain and the cooling solutions also have to be high performance. Especially in the case of cooling solutions, they have to be high efficiency and they need to be in the hybrid environment. And then finally, we have to be able to safeguard all the operations. And since we are talking about compute, and I know you've all heard NVIDIA, in fact, the first session this morning was also from NVIDIA, it's important for you to know what we do as a company with NVIDIA. So as Schneider Electric, we partner with them. And it's important to partner with them because we need to see what their roadmap is. So the partnership with NVIDIA is a technology-based partnership, which we have as Schneider Electric. We work with them on their future roadmap of compute, of the super chips, based on which we create reference architectures on how data centers have to be built. And there are some examples, you can read it on the slide, around 30, 70 kilowatt and going up to 130 kilowatt. But we are continuing to work with them to build more reference architectures on how to design data centers. So that's our partnership with NVIDIA. And we believe this is absolutely critical because the starting point of all what is needed here is coming from compute. And NVIDIA, obviously, as you know, is leading that in accelerated compute today. Now, this was actually the page I was talking about. We just took a screenshot of what Jensen was presenting. But the point here is we are talking about 132 kilowatt in this year, next year. But in just a few years, we're talking about going up to almost a megawatt a rack, 1,000 kilowatt. And if you look at the time frame there, we're talking about 2028. So that's the amount of change which is happening in high density. This is what the industry calls the AI factory. So not only does it need a different type of powertrain, it also needs to be liquid cooled. Basic physics, air cannot cool this kind of heat which is getting dissipated from this level of compute. So the future AI factories have to be liquid cooled. So at Schneider Electric, like I said, the new era of building data centers, we are looking at it from two perspectives. So from grid, which is where the energy comes from, to the chip, which is the chips. You see the chips here. And then from the chip to the chiller. And the reason we call it, because the heat then starts getting generated at the level of the chip. It has to be taken out of the white space, out of the data center. And what is outside the data center from a cooling perspective is usually a chiller. So grid to chip and chip to chiller. What do we do there? So starting with grid to chip, and this is just an example of a typical data center. This is the power train, which is from the grid to chip perspective, starting with switchgear, medium voltage, low voltage switchgears. But it's not just about having a switchgear. Let's think again about sustainability. From a sustainability perspective, you need to make sure that you have the most efficient equipment. This switchgear which we have runs on air which all of us breathe. In the past, and still in the industry, a lot of switchgear runs on SF6 gas. SF6 gas is really bad for the environment. So that's sustainability. Another example there you'll see is UPS. We all know what a UPS is. But the UPS systems which we are talking about here have a couple of things which are important. First of all, it's very small footprint, which means it needs lesser material, it needs lesser space, and it has much higher efficiency. Again, from a sustainability perspective, when you use less material, it's good for the planet because you're utilizing lesser resources. On top of that, a product like this, I mean a range like this, also has the capability of helping a little bit with the spikes which happen in an AI factory, training factory environment. Final distribution, equally important, because you create all of that, but it has to get distributed. The power has to get distributed. And then, of course, all that is put inside racks and containment. So that is what we talk about as a complete grid-to-chip infrastructure. And one of the most efficient and most sustainable infrastructures is what, of course, we want to build, and we continue to do that. Then when you take it to the other side, which is from the chip to the chiller. So now we've got all the energy in, running the chips, which are creating a lot of heat and will create even more heat in the future. We need to take that heat out. The heat has to be taken out and taken out of the data center. So very important to have liquid, like I mentioned earlier. The reason it is important is because air cannot do that level of cooling anymore. So you need to do liquid. Now in liquid, there have to be various things which need to be done. There has to be products like the first one you see there, which is liquid-to-liquid CDU, CDU being a cooling distribution unit. You need liquid-to-air type of cooling distribution units. You need high-temperature chillers, and you know, we have technologies there. Obviously, you still need some air cooling, because air cooling doesn't go away. Even in an AI factory environment, in the white space, about 20 to 30% of heat gets taken out with basic air. You still need to do that. And then, of course, the chillers. Now, this is the amount of technology which is needed. But what's important here is, and I think you would have noticed, we recently acquired a company called Motivair. It's a liquid cooling company. It's a US-based company. And the reason I'm mentioning that is, you'll see a lot of CDUs out here. You'll see a lot of technology in liquid cooling. This is the company which actually has been putting water plus glycol, into the white space of data centers in supercompute environments for the last decade. So what they have is the experience. And that's why we are very happy to have Motivair as a part of Schneider Electric. And that's why when you think about the CDUs which we are mentioning there, not only do we now have the best technology, we also have the best experience through Motivair to be able to scale it. The key now is scaling all of this. Today, when you think about the supercompute environment and liquid cooling, yeah, there is some liquid cooling which is being done for the last 10 years in certain supercompute type of environments. But now we're talking about AI factories which are getting built all over the world. So the ability to scale needs a lot of experience in this space. So we're very positive about that. You'll see the chillers which we mentioned there. So we have a turbo core technology, which is what we've had for a very long time. Again, big advantage. Now, I'm not trying to do a Schneider selling here. The reason I'm mentioning all this is because eventually, all of this high efficiency, all of this experience leads to building a much more efficient data center, which leads to sustainability. So we can have this entire demand of AI, but if we do not build sustainable data centers, it's not good for the planet we all live in, and the future generations will live in. So that's the connection we're trying to make. So in this new era of data centers, grid to chip and from chip to chiller, with all of these technologies is needed. But this is what we are doing today. What do you need to do tomorrow? Again, back to the point about the AI factories. And you've heard, I won't speak on AI factories because you've already heard a lot about the AI factories. What the AI factory means for the future is when you start thinking about a megawatt or rack type of environments, the way the powertrains are done today is potentially not going to work. Liquid cooling, you have the greatest solutions. So for the future, you need to start thinking about direct current. So 800 volt DC. When we are thinking about more than 300 kilowatt a rack, new powertrain is needed. And hence, these type of new technologies, new innovations are something which, as a company, we are working with very closely, technological engagement with NVIDIA. So how do we decouple AI data center growth with energy consumption? Because that's the main challenge at hand now. These two things, if they're completely interlocked, then it's not the best outcome which we need as a planet. So we optimize the power capacity, obviously. That's the first thing to do. Continue to deploy high density. And then, of course, enhancing sustainability, which is at the core of what we do as a company. So to do all of that, here's another example, which I'll share with you, of one of our customers. This customer is Wellcome Sanger Institute. This is a cancer research institute. So we worked along with NVIDIA, to build the physical infrastructure, helping this customer. They're using accelerated compute for cancer research, such an important issue for mankind. But by using what NVIDIA has done for them and the physical infrastructure which we provided, look at the advantages they've gotten. 1.6 times reduction in runtime, 24 times lesser cost, 42 times reduced energy consumption, and of course, a lot of financial saving, right? Close to $1 million. So this is just one example that when you use the most efficient physical infrastructure for accelerated compute coming from NVIDIA, you can help our customers, we can help our customers, and there are many such examples which we have. Now, bringing you back to what I started with, which was around the energy curves. And I showed you 4 scenarios, those 4 color lines there, right? This is another example of the work which we've done as Schneider, and this is again available. It's called White Paper 212, available for download for anybody who wants to see. What we are saying here is that with the amount of energy which is needed for AI, there is a way to bend the energy curve. And there are 2 aspects which we've covered in this white paper. The first one is around accelerated compute. More and more accelerated compute means better, efficient compute capabilities, which can help reduce the need for infrastructure by almost 14%. Then need for energy by almost 14%. On top of that, the example I gave you about grid to chip and chip to chiller, when you think about all the efficient, sustainable physical layer of powertrain, cooling train, and on top of that applying digital, which is software from a digital twin perspective, you can save another 3 to 4%. So what we are saying is, while the need for AI compute is going up like that, the energy curve does not have to go like that. It actually can be bent. Just by bending that, by doing these 2 areas, it is about 17%. And there is more. If you start thinking about behind the meter, which is not even in this paper right now, by the way, you can actually, the ability to reduce the need for energy can be brought down even more, right? So 17% is what you see here, which is again really good, because this means we can build these data centers in more sustainable fashion. And I would urge for all of you to take a look at this white paper and give us feedback. And I think collectively we can solve this problem. And then finally, so I come back to a few takeaways. The example about the potential from a sustainable digitization perspective. So I shared with you a lot of examples of the grid to chip, chip to chiller, the examples about some customers who've already gotten the benefit of utilizing this physical layer for their accelerated compute. I gave you examples of how and AI can actually help with energy even more. So the potential exists. So sustainable digitization can happen, and there are some examples which you already saw. The reduction of the need for energy for these AI data centers, which is bending the energy curve, we already shared, close to 17%. That's possible. So that's good news also. But it's also important to think about the collaboration. And we gave you one example of collaboration. I spoke about how we work with NVIDIA. But NVIDIA is making the superchips, we are making the physical layer. There are a lot of other large companies in the middle of all of that, right? Because there are these players like the Gigabytes, which you saw here, use Supercompute, and so many, Supermicro, and so many others who are building these servers. And then there are the physical layer people, which is us. There are the academia, who are doing so much of research in this area. And there's also a lot of media. A lot of media plays a very important role, because narrative is important. Because if the narrative turns only around energy for AI, then it becomes a narrative which becomes negative then. So AI for energy is equally important. So cross-industry collaboration is needed. And we can do even more from making a positive impact to the grid by going behind the meter. So that's all I wanted to share today. Hopefully it was beneficial for all of you. And of course, feel free to reach out to us at Schneider Electric, and we'll be able to answer more questions if needed. Thank you very much for your time, and you have a good rest of your day. Thank you.
Thank you, Panga, for your brilliant talk. It is indeed an exciting time for data centers, as all players are doing their best to seize the opportunity to power the next wave of AI innovation. What will the future of AI look like? To what extent can AI drive breakthroughs that profoundly change the way we work and we live? The answer lies in data centers and the immense computing power they can unlock. The race is on. And please now welcome to the stage Alan Chang, Vice President of the Infrastructure Solutions Business Group from Compal.
Thank you, COMPUTEX, and thank you for everyone staying here to listen to the session. I was told backstage I have to finish the session in 30 minutes precisely, otherwise you guys will fall asleep. So, all right, I'll go into the section. My subject is the race is on. I think everyone here is in the technology industry, and AI has been the key word for every one of us in our daily life. So, like any other race, there's a lot of excitement and there's anxiety, right? The excitement part is you're really excited about the next challenge and you want to conquer it. But the anxiety part of it is there's a lot of uncertainty and there's a lot of things you're not sure of. So today, my session, I'll try to break it down into two parts. First, what kind of challenge we're facing and what are we facing it together as an ecosystem in Taiwan. So in terms of the AI demand, as we can see right here, for the past couple years, Mark Zuckerberg say there's billions of users using the Meta AI as an application, right? And Sam Altman says there's AI could be the next big thing other than internet. So I think it's real. I mean, throughout our daily life, I think we're using the AI more and more often, and the demand is there. And I think the biggest challenge we have is, do we have enough power to power all this AI silicon? If the AI demand is real, where's the demand is coming from? I think it's coming from every one of us right here. So from the introduction of ChatGPT, we asked a simple question, we expected some sort of answer. Sometimes it's 100% what you expected. But sometimes you get 50% of the false answer that you were not expecting it for. But after the technology was introduced, like GPT-4, GPT-3, GPT-4, we're expecting more and more on our daily life. Now you're kind of expecting to have a transactional conversation. They know exactly what you were talking about before and afterwards and rationalize with you. And now you want to actually type in the text and get generating an image. All these things, it's actually creating that demand. And that demand is actually going to be exponentially more and more. So based on many of the analysts, IDC and things like that, I think we will see a tremendous growth in AI demand, especially in the data center spaces. AI data center is going to be 3.5 times of the demand in the next couple of years, and that's huge. I mean, I've never seen a demand like that in my past 15 years working in server. And that demand just continue to grow. And lucky for us, there's a lot of money is going to be spent. $5 trillion is going to be spent for the next couple of years, specifically just for AI. And $3.5 billion are especially on the IT equipment that you and us are all making together in this form. So what can we expect if that's a new reality? This chart is kind of noisy in a bit, but that's how much language model or how much things that everyone is actually putting out as far as what the framework goes. A lot of people are saying AI could be a bubble, right? But the demand is there. Is there a bubble? Do we necessarily need 300-something framework or application out there just supporting what we need? Well, the analysis I have is if the large language model, yeah, we don't know who's going to dominating that. But once someone is dominating like Google Map, there's adjacent applications going to happen, like the Uber, the Airbnb, the Zillow. Those applications is available simply because there's such a dominating Google Map as a foundation of all this. So what I see is really the beginning of AI. And there's going to be tremendous amount of different opportunity for us in the future, just beyond the large language model that we're seeing today. So the data center expansion is actually happening everywhere, not just the United States, not just China. As you can see right here, United States still leading the pack for 2.5% of 2.5 times of the data center growth in the next couple of years. Asia is about 2.2, but EMEA is about 2% too, 2 times 2. So I think that's a tremendous amount of equipment, IT equipment, or data centers going to be built. And then it's across the board, not just one region, not just one places. New data center has been built in a different states, different countries, right? Traditional CSP building in Virginia in the past, or Finland, Ireland, things like that. But it's growing everywhere in the world. So I think we see a lot of tremendous momentum right there. But one of the things we have to know, traditional data center for gigawatts and things like that, because the AI power consumption requirement, all these new data centers actually require more power than ever before. It's at one side, but it could be potentially 10 gigawatt, 20 gigawatt, and things like that. One of the growing trend I see also is most of the public cloud CSPs are dominating hosting about 60% of the cloud application as we speak today. But private data center co-location, private sites, I think there's a lot of demand for it too. We'll talk about that. That also creates a new challenge, a new set of challenges that we haven't seen before. Data security, data sovereignty. How do we conquer that as an ecosystem? As far as for the data center capacity, power capacity requirement goes, I think there's a lot of really great session before me talking about power, energy efficient, and how do we win all this. But in terms of the power consumption, I just don't see a way to actually for this to slow down with the data center that we were building across the globe. I think in 2030, like 10% of the power energy generated by United States actually gonna be used by data center. I was in Texas a while ago, right? We were joking about if there's a data center right built next to you, just be careful. There's a chance your house is gonna be not having power in one of those nights, like when hurricane comes, right? So it's a really critical issue, and I think as an ecosystem, as a community, we should have the way to actually solve it together. So that's charging ahead of the curve. Why all this power? It's a simple physics. It's giving a silicon more power, it gives you more performance. Even though TSMC, all these foundries is doing really a lot of technology breakthrough, but that's simple physics that you cannot avoid. And simple because we as human beings, we demand more performance, computing power as our daily life. So power consumption is an issue. How do we solve it as a system level, system integrator to solve that? And with the thermal solutions such as BP, Schneider, and all these partners created. As a system integrator, how do we do it together? I think right now, we don't know the answer ultimately, but there's a mature single-phase DLC, there's a dual-phase DLC, there's immersion cooling. We don't have a crystal ball, but I think that's not the end of it. I think there's gonna be future that we need to develop together as a partner to solve that problem. As I start my career, 400 watt is pretty much unthinkable in terms of CPU power, right? We stayed for 165 watt for as long as I can remember for many, many, many years. But 400 watt CPU, 500 watt CPU, it's become a norm. And then we're talking about 1,000 watt of GPU, TDP. That's like the baseline of everything we actually sell today. So I think, like I said earlier, simple physics, we as human beings is requiring more performance, and then we'll be asking the silicon to actually give us performance. And then that power is gonna be unforgettable. So I can foresee there's gonna be 300 watt silicon coming out in the horizon pretty soon. And then that's gonna be a challenge that we have to solve together as a community. Another challenge I think we have is data security. I think in our daily life, we see phishing email, right? Security breach across the board. As AI growing stronger, smarter, knowing your behavior more than your family, how do we make sure that didn't happen and then someone is actually penetrating your data, personal data, and then start manipulating you as a person? I think that's one of the reasons why data security and sovereign funds and things like that, it's actually really, sovereign country is actually coming up with reasons like you have to have local security, local bill. And as a system vendor, I think logistics is also one of the areas that a lot of people not kind of missing. How do we make sure our system was delivered to a customer without tamper, right? So all this data center has tremendous amount of data, as Seagate was saying earlier. All this data is really important, including personal data, including all the financial information that we have. How do we ensure all this system going to the data center with all this access has the right bill of material that we expected and not otherwise? So that's really one of the things we think as a hardware island. I think we have to think about how do we solve that, not just the software side of it, but the hardware side of the logistic. If you do a survey on most of the enterprise or personal, on the personal level, I think data security is one of the biggest challenges that we also see, and then that's one of the area we also don't feel comfortable about providing to some of the CSP, some of the applications, and then we're just afraid that those data will be leaked out and then breached in many, many different cases. And that's maybe one of the reasons we also see data center is actually building around the world, because data will not leave that country, right, for the sovereignty of it. And compounding to all the things we said earlier, we can imagine the data center requirement across the board, across the world, is going to be more significant than ever. And I think this is a really good chart about the reason why all this country is asking for data sovereignty and data center built locally, and even the assembly of the system like we're providing to them, it actually has to build locally. All right, let's talk about accelerating together with the ecosystem. Artificial intelligence, there's a lot of different terminology, a lot of different interpretation what artificial intelligence is. I do have a little bit different view of AI myself, so I'd love to share that with you. And then in terms of how Compal is using AI and then viewing it differently. We kind of view AI in two different ways. One is centralized. This is the topic of today, centralized as a data center. But we also see it as an edge. Let's look at this. Take smart city as an example. You have latency requirement sometimes, you have security requirements, you have all these scalability requirements. So yeah, having a data center in a city, that makes sense. But what about if you need that latency become like a real time in a car? You can't wait for that latency for milliseconds, right? When you have an emergency stop, you have to stop rather than actually 10 milliseconds and maybe hit something and then stop. That's unacceptable. So when you have all this combined, I think the way we should see this is, yeah, it's great to have a data center, but what's the other end of it? And then you have to think about both ways in order to actually come up with a complete solution for the customer. So centralized AI is important. I think that's the core of everything. But decentralized AI at Compal, we just have kind of luxury, being very strong in the consumer side of the business, so we have a lot of access to it. And then we are drive to actually to have those, the synergy to it. If you look at this chart, healthcare, telco, finance, medical, all this has requirement for centralized and decentralized. And the reason why we're in COMPUTEX, Taiwan is in the center of all this. We have a really great relationship with all the upstream components and relationship with the supplier to have all this great innovation on silicons, in parts, in cables, in all this. As an ODM, which I represented, we actually put those together to the end user. But we do have a responsibility, and we have to do better to be part of that centralized ecosystem. Compal was investing in not just data center. We're also working with various different companies to create a robotic. We also want to make sure autonomous driving, something real time, is actually happened, and we have the luxury of knowing exactly what the customer wants at the end of it. We're creating the heart of the automotive, and then just make sure we have that devices to synchronize with the data center information. Healthcare. That's one of the areas a lot of people is talking about, but healthcare is important. Just a couple days ago, our company actually introduced a quantum computing project. It's a commercial right now already, working with NVIDIA, CUDA-Q, to provide CDMO, to make sure we have optimized the medical devices, the medicine that you actually get every day. We streamline that process just like we'll streamline our processing for making notebook. So we want to make sure that's happening, and then everyone can have access to the medicine that they need. Telco, data center, 5G, that's a topic for a lot of people, and then we have that luxury to actually have that access to. With all this talking, the core of Compal is manufacturing. So we put AI into practice. We have the data center, we have all this information, we put basically server in the data center to collect data, computer vision, digital twins, things like that, to make sure our manufacturing process was top-notch. Quality, reliability, and all these standards are the best of the industry. But with all this, I think it all comes back to human, right? We are human society is the core of all these technology innovations. So everything we're doing is actually provide a better future for our human. So that's why I think every session has this page, sustainability, ESG. We kind of proud ourselves to being one of the manufacturing out there in the world to take this very seriously. So we are always in the top 10 in the industry to be part of the ESG. We take renewable energy very seriously. Every factory we're going to expand in the future is going to be having a percentage of renewable energy implemented in our factory. As we were talking about earlier, factories. This is the current footprint that we have, but as you can imagine, that's going to be more footprint, more factories going to be built around to support this demand. To closing out the session, I promise I will be closing up before 4 o'clock. Compal, we want to be your computing power for any kind of scale. From edge computing, personal computing, high performance computing, to even the future quantum computing. So again, thanks for everyone for listening to the speech, and I'll be right here, and then thank you for your participation, and then have a great of the rest of the show. Thank you.
Thank you, Alan. Thank you. That concludes the Data Center Solution Forum at 2025 COMPUTEX. While the forum comes to a close, the conversation around AI continues. Thank you for joining us. COMPUTEX is in full swing at TINEX 1 and TINEX 2 until May 23rd. Come join the action, discover the latest innovations, and experience the future of technology. AI next.